the name suggests, we all are familiar with the term magnetism. It is the property of attracting small iron filings or small iron pieces and substances which show this property of attracting small iron pieces are called magnets. Naturally, certain substances have or possess this property by default. Such substances are called natural magnets. For example, the ore of iron, which is called magnetite. It is found in layers of Earth's surface. This is a natural magnet. In other words, it is also called lodestone. So this ore of iron specially has the property of attracting small iron pieces naturally, and hence we call this as natural magnet. But this ore found is of irregular shape and shows very poor magnetic properties. It is very weak magnet. To overcome these difficulties by using different methods, we can prepare nowadays artificial magnets also. Not all substances can be converted into artificial magnets. There are certain substances which can be converted as magnets. Such substances are called magnetic substances. The process by means of which these magnetic substances are converted into artificial magnets is called magnetization. Certain magnetic substances get magnetized. We magnetize them and we prepare artificial magnets of desired strength and in a desired shape and size, which overcomes the difficulty of natural magnets. So what are magnetic materials? For example, iron, soft iron. It can be easily magnetized and be converted into magnet. So these are artificial magnets. So irrespective whether it is artificial or it is natural, every magnet has certain common properties. Artificial magnets can be designed in different shapes like bar magnet, horseshoe shaped magnet, disc shaped magnet, circular magnet, etc., etc. Irrespective of their sizes or irrespective of their nature, each and every magnet have or has certain common properties. We study these properties one by one. So let us discuss the first property. If you take any magnet and dip in iron fillings, suppose this is the paper and these are the iron fillings. If I place the magnet in this iron filling, it is observed at certain points you get maximum iron filling slug. And there are only few negligible at other points. So you get 2 points in the magnet where these magnetic properties are concentrated, are strong, and this part is called pole of a magnet. So each magnet, artificial, natural, of any shape, has always 2 poles. In the magnet, you get 2 points where magnetic attraction is maximum, and we label that points as magnetic poles. So always it appears in pair. वो दो रहते हैं, एक अलग नहीं कर सकते. So this is its first property. Poles exist and they always appear in pair. By any known method, you cannot separate them from each other. So monopole never exists. This is the second property. If, for example, if I have one magnet, so name of the pole. अतः ये poles के नामकरण कैसे किए जाते हैं? You have to keep this magnet freely suspended with the help of stand. एक stand लेना है, freely suspend करो. It always rests in geographic north-south direction of Earth. Pole or the end of magnet seeking to geographic south is called North Pole, and the pole of magnet seeking to geographic north is called South Pole. South S pole, and this is N pole. So pole of the magnet seeking towards geographic north is its north pole, and the other is labeled as South Pole. So these poles are dual nature. They always appear in pair. So this is its second property. Third one, if you try to break this magnet into pieces, suppose 2, the original pole remains as it is at the same position, and new poles of opposite polarities automatically appear at broken ends. Opposite polarity, so here N रहेगा, इसके against here S रहेगा. So if further the same piece is broken into next 2, or if you break the magnet into very small tiny particles, even each particle behaves as a complete magnet. So these poles cannot be separated. Simplest structure in magnetism is magnetic dipole. Monopole doesn't have its own existence. इलेक्ट्रिक चार्जेस के बारे में क्या किया था हम लोगों ने? They do exist isolately. पॉजिटिव का खुद का एग्जिस्टेंस है, नेगेटिव का है, लेकिन इसके यहाँ ऐसा होता नहीं है. पॉजिटिव नेगेटिव ऑलवेज appear in pair. What happens if this break the magnet at point C where earlier pole was not present? Pole appear. If further broken at this point D where earlier there was no pole, this point D, these two poles appear at broken ends. These two poles are of opposite nature and have same strength as that of the original. Original जो strength है ना, उसका strength वैसे ही रहता है. So there is no such fixed position, one particular point in the magnet which can be labeled as its pole. These thus are called fictitious in nature. So what next? Third and fourth property? Monopole never exists. Fourth property, the poles are fictitious. You cannot locate any one particular point in the magnet as its pole. For given piece, you can label the poles, but if it is broken, then new poles always appear at broken ends. So no one particular point can be labeled as the pole of a magnet, and hence it's called fictitious nature, or they are fictitious in nature. This is its next property. The simplest structure is magnetic dipole. So we consider always magnet as a dipole. Monopole never exists. Simplest structure for particles most commonly used is bar magnet. So we will proceed further to study the characteristics of bar magnet, which are written on page 222. I have started article 12.13. 12.3 bar magnet. I will continue the article 12.2 जो है ना पिक्चरल रिप्रेजेंटेशन ऑफ मैग्नेटिक फील्ड, वो हम लोग बाद में डिस्कस करेंगे. So using this we will proceed further with simplest structure most commonly practically useful is bar magnet. So what is bar magnet? It is dipole. These two poles are separated by some finite distance. These poles are not located exactly at the edge. Edge के ऊपर वो नहीं locate होते हैं. Both lie a little inside the edge. So exact position. Suppose this is A and this is S. So they do not lie exactly edge, but a little inside the edge. And hence, if you join these poles, the distance between two poles, not edge, is called magnetic length. It is represented by symbol 2L. The distance of any one pole from the center of magnet, center means geometric center, is called half the magnetic length. Half the magnetic length ऐसा बोला जाता है, वो L यूज करेंगे सिंबल इसके लिए. Isn't it? So pole has ability to attract the small iron piece. Means what? Each pole is able to produce its own magnetic effects in its surrounding. बराबर है ना? नहीं तो अट्रैक्ट कैसे कर जाएगा? उसको कुछ एबिलिटी है. So that time each pole is respective where it is N or S has ability to produce magnetic field in its surrounding region, to produce magnetic effects in its vicinity, and that particular area near the magnet where magnetic effects are observed is called magnetic field for a given magnet. So magnetic field, the magnet develops, we'll continue the meet. Magnetic field develop हो जाता है. So what happens, since both are in pair, we say this magnet has certain ability and it is given by its dipole moment. Analogous to electric dipole. Electric dipole में हम लोगों ने क्या किया था? एक स्ट्रक्चर बनाया था जहां एक पॉजिटिव चार्ज था, दूसरा नेगेटिव चार्ज था, and this was electric dipole. Electric dipole is associated with dipole moment. Similarly, each magnet has its own magnetic dipole moment. It is represented by symbol small m. For bar magnet, dipole moment is the product of pole strength and magnetic length. So pole strength of magnet is represented by symbol Qm. For N pole, the strength is considered positive. For S pole, it is considered negative. Q minus Qm. So Qm into magnetic length is called magnetic dipole moment. So each magnet by default possesses its own magnetic dipole moment. Depending on the value of M, the strength of magnetic field produced can be calculated. So each has dipole moment. Strength of pole, which is called pole strength, is having SI unit एम्पियर मीटर. वो उसका SI यूनिट है. वो कहां से आया वो हम लोगों को इतना अंदर तक जाना नहीं है. खाली ध्यान रखो पोल स्ट्रेंथ इज ऑलवेज एक्सप्रेस्ड इन एम्पियर मीटर. Thus, dipole moment will have SI unit ampere meter into meter, that is ampere meter square. So, non-zero value of dipole moment gives ability for the magnet to produce magnetic field in its surrounding, similar to the electric field produced by isolated charge or a system of charges together. वो तो हो ही जाता है, वो तो ध्यान रखो. So you get analogous terms can be used to relate electricity and magnetism. Both are interlinked. So few analog terms they have listed in a table on page 223. 223 के ऊपर एक पेज दिया है. देखो आप लोग सब लोग देखो पेज 223 टेबल नंबर 12.1. Are you getting? I hope everyone will get it. वो बेसिक फिजिकल क्वांटिटीज रिलेटेड करनी है. इधर आइसोलेटेड चार्ज एग्जिस्ट है, यहाँ आइसोलेटेड पोल एग्जिस्ट नहीं है. सो बेसिक फिजिकल क्वांटिटी इन इलेक्ट्रिसिटी इज आइसोलेटेड चार्ज, where basic is magnetic dipole. Poles always appear in pair. Monopole never exists.
Similarly, the line joining the two poles passing through the center we can label as magnetic axis. The line perpendicular to axis passing through the center we can label as magnetic equator. देखो बुक में सब दिया है. We have to focus on that. O is called the center of a magnet. If you measure distance between their edges, because location of poles is inside the magnet, so many times 2L cannot be measured. Instead, you can write this M in terms of non-measurable quantity, which is geometric length. The geometric length is distance between two edges. It is always greater than 2L. Magnetic length is related with geometrical length by formula. Magnetic length is equal to 5/6 times its geometrical length. ये फॉर्मूला भी आप लोगों को याद करना है. Many times we need this while solving the problems. So this is all about the bar magnet. Like electric dipole, आप लोगों ने electric dipole का study किया है. So electric dipole, what it does, it produces electric field in the surrounding. Magnetic dipole will produce magnetic field in its surrounding. Dipole, equal opposite. पोल स्ट्रेंथ तो दोनों की सेम है इन मैग्नीट्यूड, बट नेचर अलग अलग है. सो विथ एनालॉजी बिटवीन इलेक्ट्रिक डायपोल, दैट इज इलेक्ट्रिसिटी एंड मैग्नेटिज्म, वी डायरेक्टली विल फाइंड वैल्यू ऑफ स्ट्रेंथ ऑफ मैग्नेटिक फील्ड. स्ट्रेंथ ऑफ मैग्नेटिक फील्ड फॉर सपोज अ बार मैग्नेट. कौन सा भी मैग्नेट यूज कर सकते हो. सम पॉइंट्स लाइंग ऑन एक्सिस, फ्यू पॉइंट्स लाई ऑन इट्स इक्वेटर, और थर्ड ग्रुप अ कॉमन पॉइंट नाइदर लाइंग ऑन एक्सिस नॉर ऑन इक्वेटर. सो दैट इज जनरल पॉइंट. सपोज द जनरल पॉइंट. सो विथ एनालॉजी टू इलेक्ट्रिक डायपोल वी कैन फाइंड magnetic induction. The strength of field produced at given point is expressed in terms of magnetic induction. In electricity we use it intensity, इलेक्ट्रिक इंटेंसिटी बोलते हैं ना इलेक्ट्रिक फील्ड की। मैग्नेटिज्म में मैग्नेटिक फील्ड की इंटेंसिटी नहीं बोलते, उसको बोलते हैं इंडक्शन। So magnetic induction is a vector quantity. It has magnitude, also has direction. So tomorrow at exact 10 o'clock we will continue to study value of magnetic field at general point by knowing its value at axial point and equatorial point, taking the analogy with electricity. So I am stopping here today. Let me know your queries. Few chats have come. Let me read the chats. 1 minute. Madam, can you send assignment work for lesson number 11, 30, 10, 11, 13, 14? Definitely, I will provide it. I am going to provide it soon. My opinion is, if time permits, I want to solve few problems from exercise of the book. So, if possible, I am giving you additional questions which are not included in the exercise. Everyone has to prepare for the exercise and also solve the keyword chapters. So today what we discussed about common properties. There are questions in the exercise. Don't move. Don't go away. Stay tuned still. I have not completed yet. 5 minutes more. So open exercise पेज नंबर 228 228 में देखो एक्सरसाइज में फ्रॉम क्वेश्चन नंबर 2 में देखो व्हाट हैपेंस इफ बार मैग्नेट इज कट इनटू पीसेस you can cut it horizontally also. I have shown the pieces made by taking its transverse section, vertical section. You can cut it lengthwise also. All pieces will have equal length. Only that time thickness will go on reducing. So this is called horizontal section. This is called vertical section. So what will happen? That you try on your own. If not got answer, tomorrow at the same time we will meet and we'll solve few questions from exercise also. So tomorrow again we'll meet by 10. If any queries, directly unmute yourself. What I will do tomorrow, today up to today I have muted everyone. So I will make the settings such that everyone, if only genuine, will self unmute and will talk to me. So that way also we can do it tomorrow, isn't it? So I will let each and every student to communicate with me by unmuting himself or herself. So be present at 10 o'clock tomorrow. We'll continue with the further discussion. I am closing the meeting. Have a good day. Have a good day. This is the last lecture. Everyone has to be there up to 10:30. So we'll meet tomorrow by 10 o'clock. Again, this lecture for second language I will conduct for tomorrow also. So thanking you a lot. I am closing the meeting for everyone.